All right, you guys should be able to hear me. You guys should be able to see me. All right, so what are we doing today? I figured since I only have a few hours before the wife gets home. Hey, El Nagger one, what's up? Yeah, I'm just gonna hang out and work a little bit through the course that we've put together for getting into Linux in the enterprise. Oh, you don't hear me? Hold on a second. It looks like you guys should hear me. Yeah. Looks like my microphone's on okay. Yeah. Make sure that yeah, Kevin, can you hear me okay? I'm seeing somebody say they don't hear me, so that's worrisome. But it is Friday. That's true. That's true. It is Friday. I'll make sure you guys can hear me okay. Okay, you're hearing me good. All right, then it's probably just on El Nagger's side of things. So I'm going to move this up a little bit. And what are we doing today? We're going to get into this course that we have. This course is free. You guys can go hop into it anytime. I'll link it to you guys over here and over here. It's also available through the Discord and stuff. I'm just going to go through some of the topics from it today. Probably see what I can get to. Won't get through everything because it's a pretty long course. But we're going to go through this. So I'm going to go look. I'm going to skip over the course project because that's not really that important for right now. And I'm going to start on the intro and Linux file operations. So we're talking about in here what you want to be able to do inside of a Linux environment to get the job, right? Those 16 weeks worth of material that we put together are kind of like what I think you guys need to, I don't know, just know how to do to be a basic Linux admin, right? Like a lot of the stuff you're going to see like, oh, hey, I do know how to do that. And I do know that from like doing home stuff and home lab stuff. But we try to kind of formalize it down into kind of knowing what you're doing. Yeah, Shadow, hopefully you guys learned something new today. That's always the goal. So, so the first thing I think, I mean, we talk about this. A lot of this comes from the guys that are in the course that kind of went through the course and then they went and wrote a lot of this out. But as far as getting into systems, and we're focusing on Red Hat Enterprise Linux, but we're doing it with the free version called Rocky Linux. So Rocky is by CIQ, a little bit different company, a little bit different support structure and that kind of stuff, but you can have support with them. They are in a lot of government systems that I build. But one of the main things you need to know is command line proficiency, right? You need to know your way around a shell. You need to be able to navigate the file system, manage processes, and automate scripts. Those are probably some base little things that you need to kind of learn how to do to be, you know, just a Linux admin, eventually turning into hopefully a Linux engineer and all these other types of things that you can do in your career. You need to know how to use text editors in some way. So many RHEL systems use VI Vim as a default editor. You got to know how to use the tools, right? You got to know that sometimes people ask me, well, could I just know Nano or could I do Emacs and stuff? Yeah, sure, but I mean, most engineers I know use VI for this stuff. There's some guys I know that are hard Emacs people, but they're fewer and far between than people just doing VI. You need to understand the file system. You need to know where stuff is being stored, how to check the storage out, that kind of stuff. So we'll get into all that. Basic utilities and systems management. Yeah, you need to know what's going on inside of the system. What's going on with the configuration, how it started up, how do we troubleshoot it, what's the maintenance on enterprise systems. So that's a big part of like the whole course, right, is just going through all of this stuff. How's it going, other Kevin? We got two Kevins on YouTube side. And then Johnny, yeah, we'll do something similar to the Socratic method, but I'm just going to go through the course and we're just going to talk through some of this stuff. Learning objectives kind of line up with that. Master the command line, understand the Linux file system, understand your VI, Vim editor type things, and then engage with practical sysadmin tasks. So that's mostly what we do in the course. There's a bunch of things that you need to know about Linux. So there's a Linux kernel, right? The kernel is the underlying, it's really the engine that runs everything, right? It's what starts up the system. Everything that's running on the system is actually being run through the kernel. So the kernel interacts down with all of the hardware, all the hardware modules and everything that's connected into the system. And all processes interact with the kernel with like user and system calls, right? User and sys calls are the main two types of calls that they do. And really, at the end of the day, when you're first starting out, you really just need to know that you've got a Linux kernel and it's some version of the kernel. So if you're troubleshooting and working on Linux systems early on, you need to know what type of version of the kernel you're on. That's a very big part of it. You need to know the shell that you're in, right? The shell that you're in on most modern Linux systems is bin bash. That's going to be a common shell for you. Another way I might find the shell is I might grep for maybe root from etc pass wd, and I would see that my default shell is bin bash, but that's also what I'm using here. I can change shells. If I have different shells, I can drop into other shells. I can even see my process of the shell I'm in and then use bash to generate another shell underneath that, and this shell has a different process ID, but it shows up as, so here's 504685, here's my process 508645, and there's the, yeah, there's its parent, should be, yeah, because this is the process ID and that's the parent process ID. So here's, sorry, here's my process, and there's my grep even, and there's the parent process ID, which is the one that I was in before. Yeah. Yeah, 461. No, here it is. Here it is. This this one, and here's the parent one there. That's the parent. Yep. And then we keep digging into all that kind of stuff. But at the end of the day, like, just to start out, you need to know that you are in a shell environment, and the shell that you're using is bash. So if you're going to look up on the internet things that'll help you to move around in here, you're going to be using bash commands, right? The file system hierarchy, everything starts at the /, which is the root of the file system, and this is what we call the everything that starts from here is absolute pathing. Anything that's relative to where you're at is what we call relative pathing. So there's two types of pathing that you're going to kind of deal with. In here, you're going to have a bunch of directories, right? And there's a bunch of common directories to most all Linux systems. And you just got to kind of learn what's going on in them, right? You go down into dev here. Dev is all of your block devices, right? Block devices are devices that are attached to your Linux system, and then you can read and write in block chunks from there, right? Processes can attach and open up files and read and write into these. Typically, we interact with them by mounting them onto the file system and then using them in that way as directories, right? But that's dev. Etc is a directory that contains configs. So if I cd down into etc and ls, there's going to be a bunch in here. But there's a bunch of stuff in etc that just deals with the configuration of our file system, right? I go back to root, and I want to go look in home. Home is the listing of all the home directories of normal users. So ls-l in home, I would see all of the users that are built into the system that have home directories. Not all users have home directories, but most of them do, right? So the file system hierarchy just kind of keeps going on like that. I've mounted a few, so labs and lab work, those aren't really there all the time. Media, mount, opt, these are different ones. Media and mount aren't used nearly as much as they used to be. Media used to be when you would add USB or CD devices, but in the virtual world we don't do that very often. Mount is also similarly used to mount ISO files and that kind of stuff, or whatever you want to mount and test. /opt is interesting. Opt is also a place, if we ls-l and opt. Opt is a place that we put in third-party tools, typically. Sometimes we put our applications in opt as well. So if you got like dev teams running around, a lot of times you'll give them functionality to read out of opt, or to deploy their stuff in opt. So a lot of times we'll make that its own device, or focus on sometimes we attach our own disks to that in the virtual world, that kind of stuff. Proc is an interesting place. If you've ever heard people say that everything in Linux is treated as a file, that's true. If you go down into proc, all of the things that you might want to know about the system are in here. So everything over here, every number you see over here, corresponds to a process. So if I were to do a ps-ef grep for bash again, and I knew that I was down in this shell, right? Oh, whoops. Right, and I knew that I was in 504658. I can CD into 50564. Where's he at? 658. Yeah, 658. I should be able to CD into that directory. Am I in there? 505. Oh, that's the grep. Sorry. Where's my echo? 504658. Yeah, that pass should still be there. Oh, 504. I'm dumb. You guys gotta stop me sometimes. I said it like 30 times and then I didn't do it right. And in here, this is all the stuff that's happening with that process, right? So you can really dig down in and start to look at what's going on inside of your processes if you wanted to. You can look at, you know, if a process crashes or is having problems opening something, you can come in here and see what syscalls it's doing. You can see what kind of stack it's looking at, what kind of modules it's touching, all of the file descriptors that it's holding open. You have everything in here to see what a process is doing, right? We typically don't interact with processes like this. We do much more like PS and different commands to get information about processes, but this is where Linux is going and the kernel is referencing all of this. All the commands are checking down in proc, right? Even top. If you do top as a command, everything that it's checking right here is running out of the it's running out of that proc directory. It's touching everything in there, right? That's where it's getting all that information from. All right, so you know I'm on this Linux box. I see the version, I see the type of kernel I have and stuff, and then I need to go look at my text editor. So I'm just going down through these things. Then what are the text editors? Well, you've got a tool called VI, right? VI is and this looks like it's alias to Vim or VI improved. So it looks like I've got some kind of Vim on here. And I can get help, I can do some other things. Typically if I escape, I do escape:Q. There's a really good way to learn if you've never done VI before. The way that I originally learned it, and I think the way that really works for a lot of people, is I can just look up VI visual command or visual visual commands, if somebody will have it here. Yeah, it's typically, this is the way that I learned VI, was from this basic command right here. And basically when you drop in, you're in command mode. So you can do anything you want in command mode. Then you press certain letter keys to drop into insert mode, and you can basically act and type and do whatever you want, right? When you're ready to leave that insert mode and stop typing as like a word processor, you hit escape to go back into your command mode. And then when you're ready, you hit : to go into what I was always told, and I've always told people it's called the last line mode. And last line mode is then what you would do WQ or exclamation WQ or just Q if you wanted to quit. And there's all these different ways to write quit and get out of VI. Now, for people that are newer in this space, there are jokes up and down the internet about people getting stuck in VI. There's there's a book on, I'd probably spell the Riley book on exiting. There's a million memes on how to exit Vim. It's like a joke. Exiting Vim eventually, and it's like there's jokes all over the internet about people getting stuck in VI. We had a guy, I mean, I feel so bad about this, but like we had a guy that was in our Linux group for years. Guys, he was legitimately in our group for years, and we would always meet on Saturday nights at my house back in the day. And we were doing a project one time. It was me and Jason Hester and then this other guy, and I think my brother John might have been there. And we're all doing Linux, and we're doing all these projects and just like messing around. I used to put up on my big screen TV, and then we would just sit here and work on stuff. And we were like, hey, other dude, last guy, did you get it all done like us? Did you follow along this and this? And he's like, oh no, I'm doing this other thing. And like Jason looks over at his screen and he's like, he's stuck in Vim. He hasn't even done the first part from like 2 hours ago. And he kept coming for a while, but he didn't come much longer after that. And I kind of felt bad because like it was like all he had to do was ask us and we would have helped him. But I don't know. I like that guy, but he was not everybody wants to do this stuff, right? Not everybody wants to do this stuff professionally. But there's a tool in here. I don't think I actually have it set up, but Vim Tutor. If I have Vim Tutor, yeah, I don't have it in there. So DNF what provides Vim Tutor. We can find it, and I can do Vim. So VI, or we'll do DNF install -y. And if you're in any of these labs, you can do this as well. Let's go look at Vim Enhanced. And let's see if we can get this tool real quick. All right. That's fine. It says okay. So if you guys have never seen Vim Tutor, this has been around as long as I've been in Linux. So this has been around a long time. And what it does is it says, okay, you don't just have to be like Scott and use the arrow keys. You can come here and you can use H, L, K, and J to move around. This is for people who don't want to even move their hands off the keyboard, right? Some of you guys that do your elite, you know, you want to be elite hacksaws and you never even want to move your hands off the keyboard and you don't want to have those fancy $600 keyboards. This is the place you would go to start to learn that, right? So this is the basic Vim Tutor. It'll walk you through. It'll say, hey, hold down the J key until it repeats, right? Use the L key and go up, right? Then you hold down key and you just keep going down. So you can use the arrows, which I tend to do because I don't mind moving my hands around. And then if you ever are unsure about something, type, press escape to place you in normal mode, then retype the command you wanted. So this is one of these things like, they're talking about normal mode. Some of us think of it as command mode, you know, command line mode, last line mode. There's all these command and there's different ways that people call it, but this is their specific tutoring, so hopefully it's there. How do you exit Vim? Well, this is the lesson we were joking around about. I tend to use this one, which is, you'll see me say escape:Q or WQ, right, to right quit a file. But a lot of people like to do like, I think it's Shift ZZ. Yeah, people love doing shift, so it's 2 capital Z's. I don't know. Do whatever you guys want, right? I mean, this is the idea that you can do really whatever you want in here. But the point is, you could do Vim Tutor here, and you could start to figure out how to use VI if you wanted to get into doing it a little more organized, right? So we're over here. I think that that's good for now. I can leave VI, right? So we get out of there. That's Vim, VI and Vim. You got to understand those. And then you need to know where your systems are logging to. So in our systems, it's typically down in var log, right? So we're in var log. And in here are a bunch of things that are happening with the system. So if I did like a tail-f on var log, let's go secure, right? And I just watch that. So this is just watching the Rocky 5 server. And then if I remember where that server is, I could come over here to the Bastion node maybe, and I can SSH to Rocky 5, right? And now it's giving me a password prompt. But over here I should see some logging if this person starts giving bad passwords. I should see that there were failed passwords trying to come in from this server. This server is the one that I expected it to come from. That's my jump 02 box, right? The 246. If you can just remember the 246. There you go. 192.168.11.246. That was trying to go in there. Well, that's the secure logs. Varlog secure tells us everything that has to do with login attempts, failed login attempts, any of the actions around authorization to the system go into varlog secure. Now varlog messages has a bunch of other information that's going on in the system, and this is more interesting. Looks like I got something that's running in the system. I'm trying to grab. Anyway, so the point is there's all the varlog messages going on in here, and this is where I might get clued into messages of what's going on inside the system, right? So system logs tend to be down in varlog, right? Varlog. And then we tend to see varlog messages or varlog secure for most system messages. The definition of those is down in etc rsyslog.conf, or if it's not a directory, yeah, and then rsyslog.d. Oh God, what was I doing? You guys gotta stop me. You gotta cap the thing. And this is where those definitions are. To route everything to varlog secure, it's actually done right here. So we could actually override this. We could change auth-priv here to not log to varlog secure anymore, and we can modify that to go into messages, right? So authpriv.none is right here. So let's do something. Let's go muck around in this file just for fun. Real quick before we do, we'll copy the file always to etc rsyslog.conf.orig, right? Just so we have an original version. We'll vir etc rsyslog.conf, and then we'll set the background equal to dark so you guys can read it. And we'll come down here and we're going to change this line. So we're going to do a YYP, and then we're going to comment out the original line. We're not going to change the original line. We want to leave that there. And we're going to change this authpriv right here, instead of authpriv.none to authpriv. And then we're going to change this here for authpriv to no longer be going to varlog secure. So watch this real quick. I'm going to systemctl system status rsyslog. Right, here's our rsyslog running. We've got to restart it, or just hup it and bring it back up, right? But we're going to restart it because now it's going to go reread its config. Now, if I did that right, and I go to var log, well, we just tail it, tail-f on var log messages now, right? And I go do that same thing that I did a few seconds ago where I try to log in. Those messages should be coming, oh, they should have been coming over here. I don't see them. I've made a terrible mistake. Hold on. Authpriv. Oh, authpriv with everything. Anything authpriv. That was my bad. Dot anything. That was my bad. Let's restart the syslog again. Let's go tail our messages. I'm going to clear the screen up just so you guys can see it better. Right? So tail messages. And I'm going to do my same thing. Uh-oh. Oh, I've killed everything. I've locked my screen session, sorry. I could remember my password. Okay. I've locked it all up. That was my own fault. There we go. Okay. Let's go. SSH Rocky 5. Alright, so now we come back over here, and now we see those failed root password logins because we redirected all the messages over to that system, right? And 3Code Warrior, how's it going? Kevin Frawley with State of Hardware and Virtualization these days. Folks just parse the big log files, don't break them out as much as they used to. Still valid. Yeah, it's 100% true that a lot of the stuff I show you guys, we don't get in the weeds like this much. I do try to point that out every now and then. Like I show you guys like very simple, like crawling around down on the systems thing, but then it's very valid that like, well, shoot, we just throw this all at Splunk, or we just throw this all into some big SIEM or SIM tool, whatever you want to call it, and it just chews it all up and tells us what we want to know. That is very valid. That's a very common way for a lot of this stuff to work. Keep moving this up a little bit. Yeah, there we go. All right. Yeah, see, here's more stuff going on. But I want to fix that, so I'm going to go fix that, just so you guys can see also how I'd fix this. There's two ways I could fix it. I could just copy that file original back over the one and then rehup it, or I can do this. I can just uncomment that and then uncomment that, and now we're back to the original values that we just had. If I really wanted to, if you were like, Scott, could you really do it? Well, what I could do is md5 sum, like the etc rsyslog.conf. Is that the exact same one as the .orig that I had originally done? And yeah, they're exactly the same. My changes are exactly the same file again. Because with even with an extra space in there or an extra new line character, that wouldn't be the same file anymore, right? So, and then what do I got to do? I got to restart the system. Because services don't go and read config files until they restart. And there's a very specific reason for that. What if I had been modifying that file and I had just taken both of those out, and then I, went to lunch, or my system crashed or something or whatever, and I didn't get back in there to change it back? Well, now my system would be running with that partial config partially in place. Could do two major problems. One, it could work and everything would be wrong because it's not doing anything correctly. Or two, it could crash the system, and then the system's not, like, it could crash the rsyslog, And then either way, the net effect is logically that we don't have our stuff doing what it needs to, right? So something to think about there. And then bash scripting. We gotta understand the basics of bash scripting. You pick that up as you go. You learn basic things in bash, and then you learn how to use them. One of the places I always tell you guys to go spend time with if you need to get better at this is tldp.org. The Linux documentation project is really great for, I might say, TLDP file test, right? Like I forget all my file test operators, but I know that they exist out there, and I know how to set up an if condition with them, and I go, okay, oh, here it is right here. Here's all my file test operators. Oh, this is how I do it. I check to see that device SDA2, which is in this, it would be a SATA disk, right? And then it would be A, so it would be the first disk, and it would be the second partition of that disk, right? That's how we read that. And if it's a block device, so if dev SDA, this is just our fancy way of setting it at the beginning and then using that one variable over and over again. But device 0 is SDA2. If it's a block device, then we print out that it's a block device. That's all this is doing. And you could start to go, there's an old saying, good writers borrow, great writers steal. Go grab this and put it in your system, right? Now my systems are gonna have a little bit different block devices on them, but we could do this here in a little bit when I attach some of these disks. We'll have to rename them a little bit though, because my devices will be different. But anyways, that's something to learn about. Command line interface, again, we're doing CLI, we're in a terminal. There's a package manager, and the package manager, you need to just kind of understand that this is configured with preset repositories from the vendor, but you can make your own repositories, and you can point to other repositories if you trust them, where we can get software on our system that's not there. Now, somebody might say, why doesn't this, it's like you go buy a truck at the dealership. Well, why isn't everything on the truck? Well, not everybody wants a bed liner. Not everybody wants a bed cover. Not everybody wants one of those things that has like a ladder rack on it. Not everybody's going to use their truck for that. So not everybody gets that. And it's the same thing with servers, right? The servers ship with, at the end of the day, the kernel and the init RAM FS, that's what's needed to get up to a running system. All the other stuff, you might not need it, right? So the bloat on a server would be in the, probably in the many thousands. I wouldn't say quite 10,000, but many thousands of programs. Whereas when I run compute nodes in the government infrastructures I run in, I try to keep under 200 packages on there. I make those things as lean as possible. Could you imagine buying a drag racer, and then that drag racer has a trailer on it? You'd be like, well, I don't need that anymore because that's not what I use this drag racer for. I go and I drag this thing, drag race it down the strip. So these days you can learn a lot just by working in an editor that will use one AI platforms, have a project script, make the AI generate one step at a time. Yeah, that's true actually. Yeah, I can pull up, I could pull up right here, this is what he's saying is very true. I could just say, make a new file, make a new text file, right? And then I could just go, let's go like this, and then say header for Ansible playbook, right? And I could just leave it like this, and this thing will try to go write it for me. I don't really use this functionality, but I'm pretty sure. I might have to save it. Let's see. Once it knows what it is, it'll start trying to write it for me. It's actually kind of funny. I don't really use it for this much, but it'll. Let's hit Control S real quick. Let's just go throw it in. Let's go throw it in downloads. Let's call it .yaml, right? And then now it's going to be that, and then header for Ansible playbook. Task to, I don't know, copy files from one server to another. Typically, and maybe I got to go make sure my extensions are all turned on, it'll actually just try to go generate the code like Kevin was just mentioning. Yeah, it's an airplane that, yeah. So it's funny you say that too, because when I was in college, I had a professor who, one of his friends worked with drones, and this was in the early 2000s when they were first setting up drones to go fly around, and those things are obviously all Linux under the hood, right? And it's Linux purpose built on the chips, right? So it's hardware based pretty much as they could do it. And he was telling us that his friend was saying, Yeah, our goal is to be able to reset the kernel on that box and have it back up to a running operating system in under like 10 milliseconds. So if they had to like reset the machine over and over again while it was flying, they'd be able to do that. Yeah, Dillinger, it's Friday, man. So normally right now I do like a quick little stream and then the wife comes home and then we do date night. But it's the summer for the school district, and for summer the wife works 4/10s and then she has Friday off. So it was actually kind of funny. I went out this morning. I got back from the gym and she was on my side of the driveway. She was on the bigger side. So I go and I pull into her side of the driveway and I come out there and I had gotten these seat covers for her car. She drives a little Honda Civic, and I got her these seat covers, but I did not I thought they were going to be like 15 minutes to install. It took her hours to install these seat covers over all of her seats, but they're like really nice seat covers. Can't pay attention tonight, but I'll enjoy company while I study CCNA. Yeah, definitely. Spend some time on your CCNA. That's definitely where I would spend the time. Yeah, she's doing 4/10s for summer, so it's she goes like 6 a.m. to like 4 or something. I think maybe even 4:30 with like a lunch or something. But my schedule right now is basically 7 to whenever I'm done for the day, right? But then when the East Coast comes back to only be 2 hours off from us, I basically do 8 to whenever. So, because I mostly work on East Coast time, because most of the guys I work with are East Coasters. All right. There's a thing called sudo, right? And by the way, we're gonna go in and do the worksheet and stuff on this as well. But there's a tool called sudo, but I don't know if it's actually on here. Sudo. Sudo's not there. Should probably put these on the Rocky boxes. I thought this was on there. We can look at the installer. So DNF will go out and it'll look through the configured repositories that came with the server or that we've modified in some way. And it'll say, yeah, out there I have a tool called sudo. It comes from the repository base OS. Do you actually want to install it? And I say, yeah, go ahead and install it for me. And it'll install it. It'll do some transaction stuff. And then I can validate that I have sudo on the system like this. I can also do this, rpm-qi for sudo, and that'll give me all the information about how it was installed. If later on I'm trying to figure out how a package got on this server, I can look at rpm-ql sudo, and this is all of the files that came with that, right? And there's a whole bunch of different RPM commands that you're going to use in your career, but these are the main ones that I use. Mostly when I look at something like this, I want to know when it was installed. Was it installed as part of my base package set that came with all the rest of the server, or was it something that was added later by somebody, some other admin, somebody who's got more permissions than they should in my environment, all kinds of things that could happen, I guess. So that's sudo. We give sudo permissions later on in the labs and stuff. I'll show you guys how that works if we get there today. But mainly, these course books are out there for you guys to use. They're out on the web. I linked them earlier. So then there's processes and daemons, right? So within a Linux box, there are a whole bunch of processes running. So I can ps ef and see all of them, but that's too much to count. So maybe I do ps ef and then I word count -l to just count that there's about 113 of them. Maybe just a little less because of headers. But I can do my ps-ef and maybe pipe it through more. And I can see, yeah, there's a little header on the top. And then here's all the things that are running inside of the system, right? Here's all the processes, as it were, that are available to be seen by the kernel right now, right? These are all the processes that exist. They are in various states, and they are using various amounts of time against the CPU, and they're using various amounts of RAM. And we have all kinds of tools that we can look at to see what they're doing, right? But they have, at the left side, the user ID of who kicked them off or who owns them. They've got the process ID, the PID as most people call it, the process ID. And then you've got this thing over here called the parent process ID. And the parent process ID gives us a lot of clues about what's going on inside of the system. Mainly, one of the main ones that I try to show people is if the process ID here is 1, that means that whatever you're looking at was started by systemd. Because systemd is always the process 1. Or init in this case, but it's the process that kicked off the whole thing, right? So if you're looking at a process, right, and you're like, okay, here's a SSHD, let's say, or SSH, but SSHD. Here's all the SSHDs that are running on the system, and I should probably have, where's the server at? Yeah, here's SSHD, but it is by process 1. Why don't I see that there? Oh, here it is right here, yeah. So process ID of 1, that's the parent process ID that started 735, which is the SSHD server. So if that's the case, most of the time when I'm looking at servers that I haven't been on before, I should be able to say systemctl status for SSHD on this box. And I should see that it's got the process ID of 735, which lines up with what I see there for 735 for this process. And then it's owned or controlled by systemd, right? And I see systemd information right here around it being enabled on boot up, that it's active running right now, and then just different stuff that I can see that's going on with it, right? Unless it's uptime, then it's expensive. Oh yeah, 410s, yeah. So, you know, we got all these processes and stuff going on, and we can dig into those, and we can look at those later. And then there's a bunch with the network, right? Like, every Linux box you're ever going to build in your career is going to be attached to a network. So I often tell you guys that you do have to have some basic networking knowledge. I'm not telling you you have to be, you know, CCIE or anything. I'm not telling you have to, like, go that deep into it. But you do have to know the basics of networking. And in a Linux box, one of the main ones when you get to it, if you can't get to it over SSH and you have to go through a console, well, things could be down. But let's just look on this Rocky box here. I do IP adder, and it'll give me a bunch of information about the IP address, right? IP addresses. I see 2 interfaces here. I see a loopback interface and ETH0. Those are my 2 interfaces on this box. Loopback interfaces always exist on IPv4 networks, and they are always addressed with 127.0.0.1, which is home. For any TCP/IP, Windows, Linux, Mac, home is always 127.0.0.1. That's because that's not a standard for those systems. That's a standard for TCP/IP, right? So, in case you guys ever need to look that up, that's what that is. That's for IPv4. For IPv6, it's : 1 is the way that you say home, right? Then ETH0, which is connected out of my system, it has an IP address that is globally unique. However, there are a set of internal network ranges that can be shared because they're never allowed to be routed on the internet. Those are the, I think they're called the APIPA addresses. It's 192.168 anything, that's internal, 172.16 anything, that's internal, and 10.0 or 10.anything are the addresses that you can use internally because they can't leave your network anyways. And then you have to go into what's called network address translation or port address translation to get that to leave your network. That is not stuff you need to know for the Linux world, but it's good to know the basics of networking. So then I have my routes. I can do IP route, I can do route, and this will tell me what's going on inside of the system, right? And I see that I know these 2 different networks, and I see how to get to those 2 different networks here. But then if I have anything that's not addressable in one of these 2 spaces, it'll go out to the world. So let's do something like this. Let's say host www.yahoo.com. Oh, I don't have host. Do I have NSLookup? I need to update these boxes. DNF install host. It's going to be so DNF search all. It's systools, I think, or sysdig. But anyways, let's look for search for NSLookup. Search or what provides. Right. So what provides NSLookup? It's bind utils. All right. So DNF-y install bind utils. Let's do something real quick just for fun. Clear the screen up. Now we have those tools on here. Let's do those same IP route and route commands just so you can see the routing table built into my kernel here. And let's do a NSLookup for Yahoo. And we get an IP address right here of 209.73.190.12. And then from looking at our routing table here, our routing information, do we know how to check, or do we know how to tell where our kernel is going to send that out of our system. I'll leave that for you guys to think about for a second. Does anybody know how your system looks at that? It's going to do a process called ANDing against the subnet mask and the network to find the network. It is what's called the longest prefix match, but in this case, there's no other network. It's just the nothing else is going to match. But yes, this is what's going to happen. So here's real quick. If we look at this network, the way this system figures out what is considered the network and what is the host portion of this has to do with the number right here. So it's a /24, right? Which means that the first 24 bits of this address are for the network. They're network bits. Which means that those bits are ones, which I know this is going to, unless I pull up my other little thing, I know this is going to go over some people's heads, but which means that we're going to AND the bits against each other, and we're going to figure out, the system's going to figure out, that 192.168.11 is the network portion of this. The other part that doesn't have any bits underneath it, the 25th through the 32nd bit, are right here, and they all become 0, so they're the host portion. So all that to say, that was a lot to say. Does 209.73.190, does that part of the address match 192.168.11? Not even kind of, right? I don't even think there's an overlapping number in there. Nope. Not even a single one. So that's not the route it's going to take right there. It's not going to go out ETH0 via that. It's not going to be going to that IP address on ETH0. That's not how it's going to work. But then, is it going to match, does 209.73.190 match 192.168.200.0 and only match to the first 3 octets? No, it does not. So it's not going to go out there either. So when it doesn't know what to do with it, it sends it to the default. So it's going to go out ETH0 to 192.168.200.1, but because of this rule. So some of you might be slick and you might think, but hold on a second, Scott. All of those we're going to send to the same place, so what does it matter? It absolutely matters, because when this gets more complex, that's when it gets more complex and things start shitting themselves. You're like, why didn't I listen to what Scott was trying to tell me that day? Let's go look on one of my other boxes that has this a little more pronounced. So let's go here. This guy has all kinds of networks, right? He's got a lot of stuff going on. So I host yahoo.com, and I see 209.73.190.12, but I've got all these different interfaces. Now, some of you may very quickly go, well, it's definitely not going to be your Docker, your bridged interface. Sure, but how do we know that, right? Well, let's go look. When we look at 169.254.00, which is 16, which means these are the significant network portion right here. The other part is not that. Also, that's a network number that we wouldn't normally use. So does that match at the first 2 octets? No. Nope. So it's not going out there. Not for that ETH0. And then how about this Docker interface? 172.17, we're matching at the first 16. So the first half of this. Does that match 209? Nope. So it's not going out there. 192.168, and this goes all the way to 11 because it's a /24. Does that match it? No. And similarly, neither does that. No. Now this has a default that's going to send out right there. So the default catches this because this doesn't match any of the other rules. Now, this is a logic thing, but it's also something you have to be told if you've never known it. What does a router or what does a kernel routing table do in Linux if it doesn't know what to do? So another way to say that is if I throw away my catch-all default, can I get to Yahoo anymore? Does my system analyze any of this through these to send out, or does it just drop? Like, what does a router do? A router or routing in a kernel in Linux, what does it do? Well, I like to say that it's a hot potato. What do you do with a hot potato if you can't hold it in your hands anymore? You drop it on the floor. Well, that's what routers do. Same thing with the Linux routing kernel. The kernel table here. If it doesn't know what to do with it, it's going to drop it. So you say, how important are default routes? Well, if you want your systems to talk outside of the cluster or the networks that they know about, you have to have a default route. That's all there is to it. Because then otherwise they're not going to be able to get out of there. They can resolve the name internally if there's a resolver, DNS resolver somewhere, but they will not be able to send traffic to it. So, okay. That's networking basics. There's a whole bunch of networking stuff we're going to do. All right, there's a little worksheet. The worksheet has a bunch of different links on it. What is Vim, Linux Foundation? There's a bunch of Linux CLI cheat sheets that are good, right? People have things all over the internet, right? So we give you all this other stuff to go spin off and look at. We also have the text and the original doc of this from when we did the course. And then we have the recording from when I recorded it long ago. And then we come down here and then there's these discussion posts. So if you're doing this as part of our Discord, which we're not running this right now, but if we were, I would have discussion posts every week, and then you could go in there and you could fill out like, what are you interested in doing in the systems world? There's a bunch of questions there, and then there's another discussion post. Go find a job that you're interested in, right? And then what do you know how to do? What don't you know how to do? And how are you going to close the gap, right? What are you going to work on? And some people found monitoring jobs, some people found storage jobs. And it's like, hey, if that's what you're interested in, now we got to figure out how to get you into that, into that role or into that task, right? And then you got to start thinking about your project, because if you do this with us, we have a project that you do with it. And then there's a bunch of definitions, things that I think you need to know. And then there's some things. I think one of these used to be free. Maybe it was Vim Adventures, but I think this one, like, you pay for it now or something. Let's go look at it. I don't remember. I think this is the one. It was kind of cool. But I think we found out that you had to buy. Yeah, I think you had to buy it. Yeah. So H. Right. So I don't know. People were playing around with this. I won't play with it too long, but. The point, and then you can probably go push stuff around in there and whatever. But people were playing with that a little bit, and then reflection questions. What do you still want to think about? What do you need to learn? What are you going to use? Hold on, sorry guys, people are messaging me. All right. So we come over here. There's a bunch of labs that you can go do on Killer Coda, right? There's always stuff you can go do out there. Our labs are up on, what are we on now? So. We're on 6. Oh, we're on 9.7. So we're on 9.7 now, but that's fine. Rocky 9 something is what we have these set up for. And then you have to have root access, which you are root. Right? ID, or who am I? You jump scared me with that. Oh, that's funny. Yeah, sorry. That's one that people have been playing around with, and I never really got into it because, like, again, I've never even been all the way through the Vim tutor. I've just never played with it. But I mean, I've just been using VI for so long that if there's something I don't know how to do, I'll just go reference it real quick. And I don't claim to know like all the formatting stuff, but I can get around in it okay. So yeah. Well, it's good. So if you were doing this, maybe you go back to root and you just start doing some of these little lab warm-ups. So make directory so let's do it real quick. Where am I at? I'm in root's home. LS, I don't see that. mkdir lab essentials. CD into lab essentials, right? I can touch test file 1 and then I ls to see what's going on. And I touch test file 2, and that's going to take way too long. So maybe then I go touch test file 3 to 10, and now if I ls, that made all of those different files for me. I should have done ls after 2, but I think you guys got the like, if you're following along, you're like, well, I get it, Scott, you're making individual files. But then we did what's called a wildcard expansion, and we said make all of these files in this range for us. And you might say, Scott, could you do that to 10,000? We could do this. 11 to, let's do something simple like 5,000. There's all of them. Whole bunch of them. And if we wanted to count them, 5,001 lines. Probably because... Did I make just a regular test file? Yeah. Yeah, something like that. So, we made all those, and then I say, what does this do differently? Well, it's a wildcard expansion, right? So, if you've never seen that before, that may strike you as a little odd, but it's a way for us to do multiple things at once without having to do the same keystrokes over and over again or risk what we call fat fingering it and messing it up. So there's an answer key on GitHub. I don't like the puzzle aspect of it much, but I use Vim Ventures as a review and warm up frequently. Nice. I would also, Vim Tutor is also fantastic for just the basics, you know, knowing the basics of the thing or whatever. So, oh, and then also, I did officially get told today that I'm going to be doing that HPC thing for work. So all that stuff we were doing yesterday where we were kind of like etching it out and outlining it, I'm going to be doing that much more formally now for work. So I do a lot of, if you guys don't know, I do a lot of like just kind of nights and weekends working on my computer and stuff. So I'll be building that out as we go. And I'll probably be doing some of the stuff that I'm going to roll up into it. I'll be doing as individual pieces out with the ProLUG group as well. Like I want to do Bacula and show like a whole thing on how to do backups with Bacula because I think that's very useful. And just business impact analysis, business continuity planning, and then disaster recovery plan. Those are like all big kind of concepts in what I do professionally. So I think that that's good for people to know how to do. Okay, so anyway, so I'm here. Oops, where am I at? I just cleared in the wrong screen. I've got all these files, and I say, you know what? That's too much. rm-rf everything in here. Perfectly safe command if you know where you are. Not a safe command if you don't know where you are, or if you're just typing shit that people show you on the internet, right? Now we can touch file dot, and we're going to use host name like this. And when we do an ls on that, we're going to see file Rocky5. Well, what did that do? That did what's called an interpolation and dropped the value of what this actually evaluated to in there. Now that's the old way to do things. The more modern way that people like to do this, let's call it file1 dot. This is the way most people like to see this nowadays. And this will do the same thing. So both of those still work. Both of those still do what's called interpolation. But you don't have to use one or the other. I'll tell you the first one is not markdown friendly as much because we use markdown for other things. So literally at the moment working your head around a confusing disaster recovery plan. Yeah, C-Beans, there's a lot to disaster recovery. I try to take it I take it from the start, right? I say whatever, because you're probably in an environment that's already running, right? And that's one of the worst things is like trying to pull information from other people. So I mean, I could go into that if people wanted, but like for me, it's like get the shareholder or the stakeholders, right? Not shareholders, but stakeholders, the people that have interesting processes that need to be backed up or their data backed up. Get those people involved, get their buy-in if you can, and then get them to start doing business impact analysis. What that is if their stuff goes down, right? So it's a simple little questionnaire. If your stuff goes down, what's the effect to the business? And most people want to be as important as possible, so they're going to be like, well, if we're down, that's $5,000 every 10 minutes. If I'm going to tell you right now, if that's the answer and that's true, that's going to be one of the things you're going to be focusing on. If one of them is, well, we service 5,000 customer calls a day through this call center, you better believe that's going to be a big one, because if you have 5,000 customers a day calling you, that means that, you know, you don't want those people to be unhappy or more unhappy than they already are. So that's going to be a big one for your company too. So you're going to do business impact analysis with the different processes and start to figure that out. And then you start to figure out what's called the business continuity plans from there, right? Where it's like, okay, if that goes down, what does it take to get it back up? Well, we need the data, we need the servers. All right, well, what's more important? And what's the recovery point objective of that data? Oh, well, that's a web service app that only gets updated every 3 months, so it could be something. It doesn't change very often. Okay, well, the recovery point objective on that's pretty easy. How fast can we get those servers back up, right? And you know, some people they will just back stuff up and then assume that they have a server to bring it back with. You can't always assume you have a backup server. You may have to rebuild your backup server quickly to even be able to read those backups back off of the tapes, right? So there's any number of things like that. But anyways, that's what I do. That's one of the many things I do in high performance computers. I focus on that kind of stuff. Now let's look at this other one. We can say touch file, and then we could do either way we want to do it. I've always done backticks because I've been around for a long time. But again, none of those are wrong. And now we're going to drop in date plus %F. And then we're going to do our ls-l in the directory. And we're going to see now that made a date, and it gave us the format of year, month, day, right? Because it's today. But what if I did a lowercase s there instead? And I'll change host name over here. Oh, I'll add that onto the end. So I'll do another date plus %s dot, right? And then now we do an ls-l, and we see that now there's these lowercase s's. There's this lowercase seconds. And now I should be able to read the man for date, but I think on these I need to go re-add all the man pages to them. But date has a bunch of man pages, date, man date. And mainly we can come down here and we can look at what those different filters are. So we had a capital F, one of my favorites. It's the full date like this, but it's also the same as if you had done this, the 4-year, month and day. But what does that lowercase s do? Does anybody know what that lowercase s was showing? All those seconds. But what are those seconds from, right? Because that was some big number. That was some big weird. Oops. What was that number? Anybody know? There's a name for it, right? There's a thing that it is. It's what all Linux and Unix systems are based on, right? As far as their time, where their time starts. Anybody know what that is? I think most of you guys might. Yeah, it's the epoch. Yeah, it's the epoch time, right? So if I come back over here and I read the mandate, right? Here's the epoch time. And you can always look at it like this. So you can convert seconds since the epoch time to a date if you wanted to. So if you knew the epoch of something that happened years ago and you wanted to see exactly when it was, you could. But it should show it right here as the lowercase s. Seconds since midnight of January 1st, so it's the January 1st of 1970 in UTC. That's what's called the Unix day or the epoch time. That's the start of the kernel. Yep. Yeah, that's the start of all Unix kernels. Linux wasn't around until about 21 years later, I think. Yeah, was it 91, 92, somewhere in there? You guys can look that up. That's not so long ago. That's also the same time HTML was released, which is the basis of web pages. Before that, we used to just go on little web crawlers and find different things, but we didn't really have like markup language the same way as we do now. So the web was different back then. I think I told some of you guys, first time I ever got on the internet was in '93 at a little library. We didn't have it at home, but in a little library in Glendale, which is part of Phoenix. All right, anyway, so showing you guys all that. So what do each of these values mean? So this is kind of where you sit and think about it. You can read the manual for date to figure it out. And then I say try to set the following values in a file. Could you do a year with just 2 digits? Could you do today's day of the month? And could you do just the century? So then if you're doing this, you go and here's the actual answers. So if you just want to do date plus %y, that would give us just the 2026, just the 26 part, as opposed to capital Y, which would give 2026. And then I could say %e, and that would show me the day of the month only, which is not super useful in all contexts. And if I wanted date plus %c, would give me just the century. So just it's the 20th century, right? Is that right? No, well, it's just the century portion of it. It's 21st century though, right? But that's just giving you the first 2 characters. So that's actually funny. When I say the century, I mean just the thousands, I guess. Real quick though, you can also do this one. Wait, plus %, is it lowercase j? Does anybody know what that is? You can look that up if you want, but what is a lowercase j? And why is it important? Why might I want to know the lowercase j? So what is today? Today is May. What are we on? The 29th. So here's May 20. No. What day are we? What is this? I don't even know what day it is. Could have sworn it was May 29th. Yeah. But it's a Friday. I guess I can just do it like this. Cal, and then I can do cal. So what is that showing us as opposed to this? Does anybody know what those are? Yeah, it's what's called the Julian day. The Julian day is how many days... Yeah, there you go. Somebody had it, Julian day. It's how many days into the year you are. This is super useful because if you wanted to know what was 100 days before today, you just subtract 100 from that and you take the 49th day. Whereas if you were trying to do it in months and then figure out, okay, how many days, 30 days, half September, April, June, and you're like trying to figure out what's going on, it's easier to do math on simple, 1 to 365, right? So that's something to think about, when you're doing that. So Julian days are what you tend to do long running math on in dates. All right. Anyway, so that's just like pre-lab warm-up stuff. That's not even the lab. And then the lab for this one is we just start messing around with some files. So the lab design is to get you familiar with the basics of systems you'll be working on. Some of you will find that you know the basic material, but the techniques allow you to put it together in a more complex fashion. So let's say you were just here and you were down in this directory and we rm-rf everything, right? We just clear the directory out and we just touch fruits.txt. So we just got a file now. It is an empty file. There's no bytes in it. See, it's 0 bytes. If we cat it, there's nothing in it. Nothing to show us. It's an empty file. Basically just an inode pointing to an empty location, right? And then we can ls-l fruits, and we can fruits.txt, and we can see that there are some permissions over here assigned to it, right? This is your access control list ACLs or your permissions for your files, right? And we'll look at those here in a little bit. But then I can remove it. Now if I ls-l, it's gone. There's nothing in there, right? So that might be super simple to some of you, but some of you may have never done that command before. Any of those commands, right? So you made a file, there's nothing in it. You checked out what was in it, there's nothing in it, and then you deleted it. Okay, not much, right? Then we come down, and we can make a file without touching it. We can instantiate a file just by throwing values into the file, and the system will make the file for you. So I can echo grapes 5 into fruits.txt, right? And then if I cat fruits, I'll see grapes. And if I do that same thing again, but I make it apples 3, and then I cat fruits.txt, it's only got the most recent value, right? So that's interesting because then when we look at that, we go, okay, that's kind of, well, that's not great because I wanted to have 2 values in there, but now I only have 1. Well, we've done what's called clobbering the file. We've overwritten the 1 location. So if we want to append to the file, we have to use 2 greater than signs, right? So let's echo nothing into that file and just wipe it. Let's just do this. Just nothing into the file. Cat fruits. Nothing in there. It's empty file, right? Then we're going to echo grapes 5 in there. And we're going to say, and we could do 1 here if we want, because it's the first one. And if we cat fruits, we'll see it. But then we go to our apples and we do 2 greater than signs. And now when we cat fruits, we're going to see that because we kept appending to the end of the file, which by the way we can keep doing, it just keeps getting longer because you're appending to the file. But if you ever go back to that grapes and do that, you've wiped the file out. You've clobbered the file, as it were. That's the technical term, and I think it's hilarious, like because it's clobbering time, right? But anyways, Mad Dog, thanks for the follow. Hopefully this stuff's useful to you. We are just going through, like, this is the most basic Linux stuff in the world, but some people have never seen it, right? And if you've never seen it and you're like, hey, I need to fill the gaps in on my game because I want to do this stuff professionally, this is where we go and we start to fill in those gaps, right? This is a lab book that we put together. Our guys put it together in the Discord. It's free. You guys can you can go to this at any time. Here's the lab. Boom. Link it on both sides for you guys. Now, we can create a file with VI or Vim. And we talk about the Vim tutor. We showed that a little bit. You can also sudo -i if you need to become root. If you weren't already root, we are already root. And then it's yum. Yum is the old way of doing it. But we can do DNF install Vim if we didn't have it. But Vim's already there. And then we could VI some file.txt. And now there's nothing in here. And we can hit I to go to insert mode. It says it right there. And then just start typing these lines. Grapes 5. Apples 7, oranges 3, bananas 2, pears 6. Doesn't actually matter the numbers, but pine, apples 9, right? And if we look at that, and that's all the values we need, then what we're going to do is we're going to hit escape to go back to that command line mode or command mode. :WQ puts us in last line mode, or what I think they said earlier, it was like command lit. I don't know what it was. I've always called this last line mode. Right quit, and we're going to save that file. So if we ls and then cat some file, we should see those values in there, right? This is why you want to go spend some time with VI, because you have to be able to do that. You have to be able to get into a Linux box and go look at a config file, copy it off with some copy commands, and then modify the file in some way, restart your service, and then make the system work the way that you want it to. This is very common, like low-level tasks for admins, right? And then, yeah, we cat some file.txt, and we see that all of our values are there, right? All right. So now I can take that file, and I can copy some file.txt to backup file. Then I can ls, and I'll see it there. I can move some file.txt over fruits.txt, and it's going to say, do you want to overwrite it? And I say yes. And then if I cat fruits.txt, that is the contents, but the original sum file is gone. So when you move the file, the original is no longer kept. When you copy a file, the original is kept. In the Linux world, so the common way of thinking of that, if you come from a Windows world, is it's a copy versus a cut, right? Moving removes the original name, moves it to the new file, whereas copy leaves both the old and the new. So a lot of times you'll see me do like copy something to a .original file, and then you'll see me modify the one in place. And then if I ever need to, I'll just pull back the original file over the one that I was mucking around in. It's easier to do that than try to remember everything. So, all right, there's that. Let's see where the wife is. She's still out. It's date night tonight, so we weren't gonna have date night because the one of her friends' book clubs got moved, so it was gonna be her and all the girls doing book club night, but they canceled that. And her and we also went out last night too, but we're gonna go out. She's trying to hit 50 new restaurants before she turns 50, which is later this year, and so because of that, I've been taking her to like different restaurants and stuff around the local area, because she found out, she was thinking about it like I guess earlier this year, and she said, oh, I always go just and eat at the same places, so I want to hit like 50 new spots. So I've been helping her out with that when we go on our date nights or whatever. But Friday's date night. It's just that I can do this for a little bit before it's time to go do this stuff. All right, so now we can search and filter through files. There's two ways that we filter. So let's look at this data, the data that we have, right? If we were just to think of this as some unstructured data that we have out there, because that's really what it is. It's just a file. It's not really organized much, except it's got some value in the first column, and then that's what we would call a string. And then over here, this could be a string, but really it's probably just an integer value over here. But we're not really worried about that down in Bash. We're just looking at, well, I've got information that I can sort on across by searching for it with grep, or I can filter things down in columns with awk. Those are kind of the things that are important to know here. So let's cat out fruits.txt. And what's happening here, real quick, we're going to back up for a second. When we type something into the command prompt, right? The system's just this system, guys. It's just like it's an abyss just sitting there looking at us. Like, and I think actually this is why a lot of people don't like. This is my own theory, right? This is Scott's theory of being an engineer for a long time and 17, almost 18 years as a college professor teaching this stuff. I think some people just don't like looking at a black screen all day. I think that intimidates people. There's a famous there's a guy named C.S. Lewis. Some of you guys have probably heard of him. He wrote the Lion, the Witch, and the Wardrobe series, and very well known for his books and that kind of stuff in the last century. But he did a lot of his stuff in theater, in radio. And one of his famous quotes that always stuck with me is "Radio is theater of the mind," and that's exactly how I think of this. Just turn the text green. That's fun. Yeah. So green background instead. Yeah. Or a black, yeah. So you can do all kinds of stuff, but I kind of think of this as like people are just staring into an abyss, and then they're just, or I guess like maybe some people can't like hold in their head exactly where they're at. And I'm not saying that's like some kind of intelligence thing. I think some people just don't want to do it. They're like, I don't want to think about where I'm at in the system and then move around. Like I'm going to move up a directory, and then I'm going to move back to that directory, and then like think about where they're at. I don't think a lot of people like to do that. I think a lot of people just want to move around and click, right? And that's fine. I mean, but for engineering tasks, a lot of times we got to do them over here, right? So where I'm going with that is you've got to think about this, what's happening here. And when you're looking at this abyss, there are three major functions. There's three things that are happening in a shell environment like this. There's standard input, which is what we type in and hit enter, and then the system reads it in for us. Then there's two things that come out. There's standard output and standard error. So 0 is typically standard input, 1 is standard output, and 2 is standard error at the command line here. Click and drool, wizard monkey. I was joking around about that. I've been joking around about this since I got out of the Army back in 2003. How all I did when I was when I first started out, I was a LAN tech for a school district. So I was like putting computers out for teachers, and then I got into like networking. But I used to joke around about how Windows was just next, finish. And I'm like, how hard is that? Like, and people would get mad at me. But I really don't care. Now, what I'm showing you that for is because when I put something into standard input, then if it comes back correctly, it comes to standard out, right? And if I put it in wrong, right, that's wrong, then I'll get a standard error out. So standard input into the system, me typing, doing whatever, pressing up a bunch, whatever. Standard output is good output, and then standard error are errors that are coming back to us. The reason that's important, and you say, Scott, why did you just do that whole aside? Well, because now I'm going to start to use a thing. We did a redirect earlier with a greater than sign. Now we're going to redirect with a pipe. A pipe is shift in the slash character that's right above your return key. Actually, that's a backslash. And but this is a pipe, so it's straight up and down. And we're going to catch standard output before it comes to the screen. So it wanted to come to the screen, but we're going to catch it. It's almost like we're going to catch it and redirect it and go, nope, you're going to go over here first. And we're going to filter with the grep tool. Grep stands for GNU Regular Expression Processor, or something like that. I don't know exactly what it stands for. I think it's something like that. And we're going to look for Apple. And we are going to find two instances where the string Apple is found in that file. And you can see that right there where it found it from, right? If we wanted to, we could, before we filtered it, we could catch it and put numbers on the front and then pull it out. So this would look like this if we only did the one part. We could put number lines on the front of something, and then we can filter it after, and we would just see that Apple shows up on the second line and on the sixth line of that file. Now, you might say, Scott, why didn't you add the number line after? Well, some of you probably know real quick that if you add the number line after, well, that's really useless, because it's the order of what's there, right? There's no data there from the original file that makes it to the number line. It's because it's catching the standard output each time. So again, this is one of those things you just got to kind of like sit there and think of it in your head. That's that's funny. I don't even know what that is, but that's funny. Yeah, so we got to catch stuff out. Okay, so now we could modify this a little bit. We could cat fruits dot text, and then we could grep with capital Apple, and we find out very quickly, and you'll find this out very quickly at the command line. If you do command line Linux for more than like 3 minutes, you find out, oh, it absolutely matters if it's upper or lowercase. Whereas like Windows systems, if you do even Windows command line, it doesn't care if it's upper or lower. You have to, your file names have to be unique even if they're upper and lowercase. Linux absolutely cares about case. But we can make it ignore case with a -i, at least in the filter. So the filter can ignore case and it'll find things again. But it found everything, and I want apple. I don't want pineapple. I only want apples. And then here's the filter for that. I can drop in a caret, and the caret always will, the caret is a left select, so it basically anchors the search to the left side of the line. So right here it would find only apples because apple starts at the left, or apple, because apple is linked, or not even linked, but anchored to the left side. Now if you did that, but you threw that number line in there again, here's a little exercise for you guys to think about. Is it going to find anything now? Because we've added in some values, we've added in some data to it that's going to make it look like this. It's going to make it look like this first. Is it going to find anything on the left anymore? Because now it's got this. Is it going to find anything anchored to the left? Start shaking our heads no, because it's not. Regex skills is important even beyond the Linux world. Yeah, I used to tell my college students, I used to teach out of this book called, I think I have the book. I have every book I've ever taught out of, but it was the CentOS 7 books by Mark G. Sobel. Sobel? I think it was Sobel or Sowell. I think it was Sobel. Mark G. Sobel. Yeah, he had a Linux guide that looked like this, but it was for CentOS 7, right? It looked just like this. He's been modifying his books and doing newer ones, right? Yeah, Mark G. Sobel. And I remember right near the end of it in Appendix A was like 11 pages of just regex stuff. And I used to tell my college students, this was early 2000s, so I started teaching in 2008. I would tell my college students, December of 2008, if anybody cares, I would tell my college students, if you could just master these 11 pages right here, you could basically punch your ticket anywhere in the industry. You would be extremely valuable if you understood these 11 pages. And they'd go look at them, and they'd go, that's really hard. And I'm like, yeah, I know it is. That's what I'm saying. If you could master just regex, I really think you'd be valuable in probably any endeavor, because we're always searching for things and looking for patterns of things and figuring out better ways to find patterns for things. That's what all the guys that go drill around on leak code do. One of the guys I really like watching is Midnight Simon, and he's been on break for, oh gosh, he's probably been off for at least a month. I know he was going to go travel and stuff with his wife, but he just hammers out leak code. He worked for Google for like the last 4 years too, and then he just kind of left there because he said he didn't feel super fulfilled there. But anyways, his stuff, I don't have anything but good stuff to say about this guy's guides. They're pretty solid. But anyway, so then we could start to do things. By the way, let's test it. This is an old saying that I have as an engineer. One test is worth 1,000 expert opinions. We could sit around and guess all day, but no, that's not going to work, right? That's not going to work because the number line added information that didn't need to be there. This will only work without that pipe there. Let's see, what did you say before? NL not executes, but define some form of output, and then the result of the pipe with grep adds up. No. So those numbers are just in the file. Those numbers don't mean anything. Those numbers are just data points that we put in there. We haven't actually messed with those yet at all. But yeah, so if you're doing these labs they're free online for anybody that wants them. This is the lab book here. I'll link that to you guys. You could play around with them in our lab environment. If you're like, well, hey, how do I get in the lab environment? You go into our Discord here. Boom. Right, here's our Discord. Oops. And then you go drop into the ProLUG lab environment, and here's people using the service. Now, it's a public key. Never give anybody your private key. And then you go and you drop it in here, and then you can connect in using this string right here. Right? So if you need more help on that, just ask questions down in the Discord. Whoops. If you need more help, yeah, just ask in there. We'll help you out. But most people, I think, can get that pretty quick. And then we do run through this course every few months, but we just got done with it a little while ago, so we probably won't run this one again for maybe until the end of summer or so. We'll figure something out. But anyways, let's go. Let's look at cat real quick, fruits.txt, and we see the file. And then let's do sort fruits.txt. And I'm going to ask you guys before I do this one, if I cat fruits.txt, is it going to be the original up there at the top, or is it now going to be sorted because of the fact that we just sorted that? And what do you guys think? What do you guys think is going to be the output of this next command? Is it going to be the original one, or has it been sorted and changed, and now we're gonna have something different? What do you guys think? I'm gonna let you guys guess, unless you guys all know. It is the original, right? Because the sort command, reading a file and printing out the output to the standard output, does not affect the original file at all. So that, yeah. But again, this goes back to that saying about engineering, one test is worth 1,000 expert opinions. Let's just check. Yeah, there we go. Now we know that sort by itself doesn't modify that in any way. But what if we caught the output? So there's another sort -k2 fruits.txt. And what is that doing now? It's definitely not alphabetical anymore because O doesn't come before G, and apples definitely should be up top. So we sorted -k2. What do we think K is? It also says it over there. And you can also read the man page. But now we have two different ways to sort. We can sort here, which went by the first column alphabetically, or we did this one, which sorted by the second column, and it did it in numerical order, right? So this is actually sorted by the second column, right? So what if we wanted to now make that persistent? We could do sort fruits and then throw that into sort alphabetical. So sort fruits, if I could spell it right, and throw that into sort by alphabetical .txt, right? And then I can do that same thing, and I can add a -k2, and then I can say sort by price .txt, and then I can cat sort by alphabetical and see that, and I can sort by price, and I can see that, right? Yeah, K means column ID. That sounds right. Yep. This says key. I think we got that directly from the man page. Right? -K says it's key, but I think it's just the location. I guess you could also do a key def. But yeah, most of us think of it as columns, but it's by key, but it ends up being like a column, yeah. I think by default that's what it is. So, looking at that, we cat out both of the files, and we saw that they are, in fact, sorted by the values that we gave them, right? So we sorted originally, and we sorted out. And again, some of this might seem super, super simple to you guys. But if you've never done this stuff, this is all new, right? This is all something you got to go spend some time with. All right. Then we can do a little bit. There's some more sorting that we can do that I think is useful. We have some, I think the guys added this one, AUX, because I don't really use AUX. I use EF mostly. But AUX will give you user, PID, CPU memory. This does not, by default, give you the parent process ID, so that's why I mostly use EF, because I also care about the parent process ID most of the time. But this is now sorted, and it says this is too long to see everything, so let's use the head command. So we're going to clear the screen real quick. ps-aux, and then we're going to throw head on there, and that's only going to give us the first 10 lines, right? And the first 10 lines give us hopefully most of the stuff that we would want. But we can also sort by memory if we needed to. So here we can sort -K4, which will be the memory, N-R, and then head 10. You don't really need 10 with that, but that, and then that'll show us the things that are using the most memory. So what's using the most memory in the system right now? My werewolf client. Werewolf client is by far using the most memory. Okay. And then you can read the man page on that a little bit with PS and see what's going on. And if you wanted to see more, you can add more to that number. So instead of just 10 values, you can see like the top 20 or 40. Say I want to see the top 20. And it's going to keep counting down to where after the PSAUX, there's nothing significantly using memory in this box. There's only 15 processes that are using any real amount of memory in this box. So it's not much, right? And we can go, there's other ways that we can look at memory better than this, but this is just if you wanted to sort your processes real quick by, sometimes we do what's called looking for memory hogs. And this is a thing. There's all kinds of funny things that we do as admins, but a lot of times we got to go chase down and kill what users are doing on systems. And a lot of times we'll have scripts that look for what we call memory hogs, and then the users coming in through like their login nodes will sometimes do memory intensive stuff on their login nodes where they're not supposed to. They're supposed to do the memory intensive stuff in the cluster, and they're supposed to submit jobs. But sometimes they're like, look at this login node that I'm in. This login node has 256 gigs of RAM or in our case it's 128 cores and a terabyte of RAM, and they're like, this is good enough, and then they just start abusing the shit out of their login nodes where that's for everybody, right? So sometimes we got to come in and murk them, but this is how we do it. We write scripts that go and find who the memory hogs are, right? And then typically you'll have a name over here, and you could also go look at the exact process ID. This is a process ID here, and then go see what's going on with that. There's a bunch of ways to look at that. You get LSOF, a very common tool, and in this case I want to look at this process ID to see what the werewolf client is doing. Oh, I need to add, I thought I had all these. I need to fix these labs up. I don't think these labs have all the stuff we need for them. But here's the files that it's touching. So it's holding open. It's got this client port open back to the werewolf server, and then we can see what it's touching. There's all kinds of things we can start to go do with the process once we know the process ID, right? And we do know it. It's 736. So werewolf is using 1.24 gigs. That's probably seems a bit high, but let's see. It looks like, do I have pit stat? Hold on. Also, guys, I gotta tell you, I gotta look at something real quick. Some bullshit robocaller has gotten a hold of my phone number. Hold on. Super annoying. And it's like, it's one thing to just keep calling somebody over and over again. That's pretty annoying. It's super annoying when people do that, but the other thing, it's even more annoying when they think they should be leaving messages, right? Like, it's one thing to call me over and over again. That's annoying. I'll probably just block your phone number. But if they call you and just keep leaving messages over and over again, that's ooh. I just oh, you can't go wring everybody's neck, but you'd like to. All right, anyways, working with redirection. So there's more about redirection and filters and stuff like that. We didn't do much with processing here. We get more into it in Unit 4, where we actually start to cut these up and dig into what's going on with processes and stuff. Anyways, we come down here. We do some more with redirection. So we cat fruit, grep out apple. Already did that. And then now we start to filter different ways. Yeah, I'm not going to answer those. Yeah, that definitely sounds like fraud. Like they're trying to get me. They keep saying like, "Hey, your application loan that's partially, filled out or whatever." And I'm like, "I don't have any loans for any credit. I don't even use credit." Like, what are you guys talking about? So, like, I don't even know about that. So, let's clear this up. We could cat fruits and look at our data, right? And then we could search for apple, right? And we see apples, and then we could sort that, and that would maybe sort it if it needed to, but it looks like it's gonna not need to be sorted in any way for right now. And then we could put a number line on it, right? And they'll put a number line on it. And then we could, man, what else were we doing here? Then we were adding awk to it. So awk is a nice little command that I mostly just use to print out different values. So I'm going to print here $2, $2, and then close that up, and then I'm going to sort -r, and that gives us pineapples and apples. But why did it do that, right? Like if you think about that, why did this long command that we just did do that? Well, what I do often is I just take commands apart and I say, well, what does it look like to just print the second value? And what does it look like to just see the number lines? And then just to see it, sorted. And then to see just where we grepped apple. And then we know what it looks like when it's fully out there. But when we filtered by apple, we only saw those two lines. And then when we sorted it, it left it in the same order. So the sort didn't really net us anything here. We could probably take that out. And then we came over here and we did a number line. So it added a number line column. So now we have one. This is the 1 column, the 2 column, and the 3 column in our system. Then we printed out only the second column, so we see that. And then we sorted that column in reverse order, so pineapples came up before apples. Okay. Print command, is it the part of awk module? I'm not 100% sure. Print is its own little thing, and some people use echo, some people use print. I think print has a lot more functionality. But I don't think print is specifically part of the awk module. Like, I think you have print even if you don't have awk. I'm like 90% sure of that. But I don't use a lot of print. And even if I did, print and awk are always there for me. So we have a few guys that do a lot with print. The guys that I would ask more, that know more about that than me for sure. Sending rounds. He's always down in our Discord. I think he's not one of the mods in there. I think he's one of the mods up here for me on Twitch. But he's also been around a long time. He's coming to talk to us in August at our we have a big conference in August that we do virtually, and he'll be coming and talking at that one. His talk has probably got the most people coming to it so far because it's got the best name. It's the most interesting. Look, his talk is systems engineering and AI, how I learned to stop worrying and something. He's got the most people coming, 17 so far. But people will come to all of them. They'll just keep flooding in. But I think his is still the most, 17. Let's see if there's any more. Late Night Hangout, Spiffy, and Zero Trust Models. So Spiffy is a book that's free out there on. It's a method for zero trust authorization, right? ZTA. Economics is going to be Dr. Matsu Suri, and then we're going to have Sending again has the most people coming because he's talking about systems engineering and large organization and navigating the coming AI landscape, what he's doing with it, because everybody's worried about that. So, or a lot of people are worried about that. So he's going to talk about that. RHCSA, that's one of our guys. Stovepipe's going to be there for that. King Buns is just running like the after hours, just hangouts for people that want to hang out late. Jared's coming. Burninator. The Thinking Like an Attacker one is pretty big. He's got a book too, so obviously he's probably going to tell you guys a little bit about the book. And then mine is, I love this talk because I don't actually talk specifically about any one type of engineering. I talk about engineering in the, I don't want to say the abstract, but I talk about like the core concepts of engineering much more than I talk about, like, I'm not like directly on Linux or anything. It's more just like what engineering is and why we want to be engineers. So, but this talk's been pretty well received over the years. So that's our stuff. There's a bunch of stuff that's coming up in Discord. You guys can go look at. All right. So anyways, we keep going through this. We can keep sorting this stuff down and doing all this stuff. But what I'd like to show you guys with this, as you get into redirection and filtering things with the pipe command, another thing that I would kind of posit that's useful to do is cat out your etc passwd file. So this is a file that has all the user definitions in the system, right? When I say ID root, the system goes and looks at a few different core, what we call the shadow files, to figure out what's going on with the root user. It found the root's user ID right here. It found the root's group ID right here. And then it found any additional groups that root belonged to in here or in the groups file. So let me prove that to you real quick. Let's do an ID for Scott. There's no Scott user. Let's do a... Well, let's see what users are there. We could just make a user real quick. So user add Scott. Let's just do that real quick. That's fine. We won't get a home directory for him, but ID Scott. And if we were to clear this, ID Scott, and then cat r etc passwd, we'll see Scott at the bottom. And he's in 1002 and 1002. So if I do that ID Scott, I get those two values there. But let's go see if we were to grep wheel from etc group. etc group, yeah. Oh, we don't have wheel in there? Oh. You guys gotta stop me, man, I'm telling you. There's wheel. Now let's vi etc group real quick. Go to wheel. Wheel, if I can spell it right. And let's add Scott right there to the wheel group. Now, let's cat etc password. Let's grep wheel. And now let's look at the net effect of when we do an ID of Scott. We're going to see that Scott is in, his user ID did not change. It's still the same right there as 1002. His primary group ID is still 1002. But now his groups are Scott and wheel, because he's in the wheel group here in etc group. Now, you can go do group add and group mod and user mod, and you can go do all that stuff. But you can also just go put it directly in the Linux box here. And you say, well, Scott, I would never do that because I'll do it all with Ansible. Yeah, I would also do this with Ansible if I was doing it across like 1,000 machines, or if I was building it into like my build process. Absolutely, 100%. That's how you do it. But if you want to go see what's actually changing on the system, this is where it happens right here. So the reason I showed you that was because we just filtered and we did some aux stuff, but the aux stuff assumed that we were using spaces, right? There were these spaces there, and that was causing this to work this way. So let's play with awk, but in a different way with a different type of field delimiter. So let's cat etc passwd out, right? And that could come to the screen. But we're going to do an awk with a field delimiter of colon, because this is a colon separated field. There's 7 fields across here that are all separated by colons. You guys can count them if you don't believe me, but that's what they are. The first one is the name. That's the name that your system's going to translate for you. The second field is the password, but the password's no longer kept in etc group or in etc passwd because everybody can read etc passwd. So the password with the X, it denotes that it's saved over in etc shadow, a file that nobody can read. The only thing that's supposed to read that is the PAM directory, the plugin authentication modules. Those are the only things that are supposed to read that. Here's the user ID and the primary group ID for the user. Here is this is what's typically just a description field, and you'll see sometimes people actually use it as a description field, and that's wonderful. Then here's the home directory. This is the 6th field, it's the home directory. And the 7th field is always your login shell, right? So the root user has /root as his home directory and bash as his shell, right? Bin bash. So if I do awk printf, maybe I only, or with the capf, maybe I only want to print the, let's say I just wanted the first field. Let's say I wanted the first field, and then I wanted the 6th field, and I wanted the 7th field. Right? And now if I do that, I get all of this information, But then maybe I've got a security finding, and the security finding is that I want to know, or the security team has asked me, what users inside of this system can log in to a shell. Okay, what users can log in to the system? Well, now I might grep for bash right here, and now I would see that the only two from those, because remember the last field is the shell. The only users on this system that have a login shell are Root and Scott. Those are the only two. And if you ever use like plugin scanners like Nessus or some of these other tools that go with Tenable Security, those type of tools that go out and scan your environment and check for configurations to be within your whatever your security posture is, that kind of stuff. Yeah, did I spell wheel wrong? Yeah, I spelled wheel wrong because I can do some weird stuff sometimes. But what will happen is maybe there's a list of authorized users, and if they find users that are not supposed to be able to log in, then they'll do scripts like this, and they'll just go check real quick and parse through a system very quickly, because deploying these kind of checks on systems is like nothing to the system. It's a very quick little check to do, and they'll go do it to make sure that nobody's adding users or modifying users on the system, giving the ability to log in, any of that kind of stuff. So you'll also see that node exporter, I used this is an old way we used to do it. We do bin false. So I did that manually a few months ago when we were building this out. But a lot of times nowadays it's like sbin no login. But bin false is also not going to let them drop into a shell, right? So real quick, watch. So let's test this on this box real quick. So I am the root user. I SU to Scott because I can do whatever I want. I'm root. But I can't change to my home directory, that's fine. But then I say ID, I'm Scott, echo, I'm in a bash shell, right? I'm in the shell. Hey, how's it going, Saint Device? We're just going through some Linux stuff. I'm just showing some basics and showing people what the book looks like. Also, one of the guys did write it where you can download this whole thing as a PDF. So if you don't want to look at it on the web anymore, you can download the whole thing as a PDF. I think it's 500-600 pages, some huge amount of pages. So anyways, real quick, I'm gonna exit out here. So now let's just look here. I'm back in my old shell, but you don't need to remember that, but I'm back as the root user. Let's vi etc pass wd. Let's shift G to the bottom, and then we'll go over here. We can do a $$ if we want, and we're gonna make the Scott user bin false. Now I'm going to do the same exact command. I'm going to SU up to Scott. And what do you guys think is going to happen? I can't become the Scott user anymore. He doesn't have a shell. Root can do anything, but root can't go in to an environment that doesn't have a shell. Even root can't do that. That'd be like, you're really good at card tricks, but that doesn't mean you can go walk off a building and walk. Like you're not that type of magician. You're a little trickster, right? That kind of stuff. Yeah. You really can't use anything under. I wouldn't use anything under 200 anymore, even for that matter. But that, by the way, in case anybody's wondering, is in the etc login.defs file, right? And in the login.defs file, there's a bunch of information in here around. Should be right here what the user ID, min, and max are for the system. Now, you could modify this down. Let's say you have a process coming in from Windows like LDAP or something, and then you're using SSSD to allow or trust a certain thing. You could, and maybe you set those IDs over 50,000, right? So now your UID max for the system might only be 50,000. You can set that here, and your system will never assign something above 50,000 then. And then you could go and take the, that tool or whatever that's going to make users that are authorized or not authorized to get into your system. Yeah, under 1,000 is not allowed. Yep. In most modern Linux, we set it right here. So login defs is where that's set, right? But the system minimum are 201, so it's typically 0 to a 199 or 200 now. So, all right. Yeah, and then you just keep, guys, you just keep going through here. You just keep adding stuff in, errors, show you how to read stuff. There's some scripting, some basic little scripting happens here. Yeah, this one keeps going. And then I get into permissions a little bit because permissions are important. If we clear this, if we CD back to just the root of the file system, ls-l on everything, you get a whole bunch of just gobbledygook over here if you don't know what's going on, right? So there's a bunch of things over here that need to be kind of talked about or known, how permissions work. If you ever wonder where people got the 4, 2, and 1, it comes from binary permissions, right? It's binary on or off, but 2 to the power of 0, what's anything to the power of 0? The number 1. And what is 2 to the power of 1? Any number to the power of 1 is itself, so that's the 2's column. And 2 to the power of 2, well, what's 2 times 2? 4, right? So that's where those numbers come from. So if you ever heard people call those octal permissions, or they say it's because the counting numbers, the states of nature it can be are 0, 0, 0 through 1, 1, 1, or the number all zeros is 0, and the number of all ones would be 7, because it's a 4 and a 2 and a 1, right? Because that's the column places. Well, what it ends up looking like then is over here, the permissions are right here, right? Or here. And then this part over here tells us whether it's a directory or not. So this is a directory. This is a directory. Now, you very astutely may have come over here and said, ah, Scott, I knew they were directories because look at the cool colors. The colors aren't always there. Well, in modern Linux, they're going to be there, so that's fine. But some people strip them out of their shell anyways. But I would know what the directories are here, even if this was all white, because the D over here would tell me that's a directory. The dash lets me know that it's a type of file. And then the L lets me know that it's some type of link, right? Those are the common things you can see over here, right? Now, the permissions are right here. So if I were to read these permissions for init is a 755 permission set. You say, how do you know it? Well, because read, write, execute are on right here for the owner of the file. The owner of the file is defined right here. So 7 for the owner of the file by the user ID. That's the user owner. Then the group owner is, there's a 4 and a 1, so we add that up and make it 5, but you should be able to do that after you do this for a while. You can do that in your head. So that's a 5 for the group. The group is defined right here. And then you've got 5, which is read and execute permissions for everyone. Everyone is not defined here because everyone is defined as what's excluded from either the user owner or the group owner. And then everybody else, right? It's a catch-all. It's like a wild card for everyone. So that's how you read those. So look at this. The root's home directory is sitting right here in slash. So here's slash root, the root of the file system, and slash root is the root's home directory. What are the permissions for root's home directory? Who can go and read or get into the home directory for root? Link to both, to the file and to the directory. Yeah, you can link to a file or a directory. Yeah, you can link a directory. In fact, bin is just a link over to user bin. Yeah. And lib is user lib, and lib64 is user lib64. And that's because they used to be, everything used to be user lib and user lib64, but in like modern rel, they've shoved it all down to just bin and lib and lib64. So then the link just goes to the places that sometimes they're still put into by Red Hat Package Manager. And I'm sure one of these days that's all just going to be folded down into just lib. Why temp directory is so brightly green? Well, that's got more permissions on it, right? And we can go look at what those permissions are as well. Well, we can see what they are here. Yeah. So, by the way, these are the simple permissions. There's some other permissions that you can add too. There's extended access control lists as well that can further move this down. Where's that? Was that user local too? Oh, they're doing the same thing with that. That's probably true. All right, so anybody that was trying, this permission is 700. So root can only be So it's a read, write, execute. Now, directories can't be executed, but directories can be traversed. So what do I mean by that? To be able to traverse or go into this directory and actually have a process in that directory, you must have an execute bit for your permission. So people are like, oh, I'll just give 644 to a directory and then people will be able to get in. No, they cannot traverse the directory unless they have an execute bit set. That's a directory traversal bit for directories, right? So can the group owners, so people that are in the group root, can they get in root's home directory? Nope, they sure can't. And can everyone else get in root's home directory? Oh, hell no. They shouldn't be able to, right? But we see that permission right there. So another fun one is ls-l on etc shadow. Nobody should read shadow. Shadow's the only file I know of that looks like that. No permissions to it. The only thing that should be able to touch that are your pluggable authentication modules when they're authenticating stuff that's happening in your system. Now, can we cat that file out right now because we're root? Yeah. But should we be able to? No. Root can do whatever it wants, though. All right. Anyway, so that's all permissions up there. I wrote that out a long time ago for a different project, but permissions, stuff like that for you guys to study. Then there's some bonus stuff that was added. So Vim fundamentals, some other stuff to go play with, and I mentioned a bunch of this stuff. I do :WQ, but Shift ZZ will also save and quit. Create 5 different files, practice mode switching 50 times, so go into a VI session and do those things. Write and save the content in each file. Practice recovering from common mistakes, so accidentally press keys in normal mode, forgot to enter insert mode, trying to quit without saving, like what are the types of errors that you're going to run into, and then go make a little bash script template. Put a shebang line at the top. If you don't know what a shebang line is, you might have to look that up. Let's go here, and then vi, some script .sh. A shebang line looks like this, and it tells the system what the interpreter is. Now, it would interpret it as bash if you didn't tell it otherwise, but you could put other things in there. And if you didn't know what to put for your where bash was, you can always say which bash in your command. And oh, I'm in user bin bash. Where's bash? So on this system, the correct way to do that would be user bin bash. However, user bin just pointed to bin anyways, right? Wasn't that one of the things we just saw? Didn't bin just point to user bin anyways? So it would have found it anyways. But the technical place was over there. Yeah, VI actually is that. We had mentioned that earlier. Yeah, when you go into VI, is it actually pointing to Vim or not? But it is on the system because we added it. Most rel boxes come with just tiny Vim or tiny VI. Yeah, it's just the old VI. Yeah, it can definitely confuse people. So VI some script. Set that for you guys. And what does it say to do? Put some comments. This is a comment on what I want to do. Maybe what I do is something that I commonly do. I'll have this, and I just copy this. I don't write anything more than once. But I might do something like this. And then I have a few things that I always put in a file. Author, Scott, right? And then maybe I have down here purpose. And then typically I would change this to something like date, so that we know last time it was, or when it was created. So date would be 29 May 2026. Whoops, 2026. And then I may have something here like version 1.0 or something, right? And then I can even have changes up here. But the point is, then I could know what's going on. Those are all comments. None of that's going to be interpreted or parsed or any of that kind of stuff. And then variables, right? I can set variables inside of the system. So I can say date is equal to some exact date at the time that we do this. So maybe let's do well, there's a bunch of variables, I guess, that we could use, but we could set up some basic variables, and we could also do simple functions in here, right? So we won't worry about making those right now, but I guess if we wanted to, we could set, let's just say start time like this is equal to, I don't know, something like this, date plus percent %f, and then maybe, yeah, let's just do start. I think we can do percent %t as well, like that, right? And that would be start time, and then maybe we just echo start time. Something like that, right? And that could be our script. And then now, if we try to run it, it's not going to work. But why is it not going to work? Well, because we don't have permissions to run it. If we do an ls-l, it's not executable. So we chmod it to be 755 for some script, right? Now we can run it, and it gives us some timeout, right? That's the date time that we had crafted from this, right? And then this just starts getting more complex, and there's more and more things, and there's all kinds of places you can go for that. We have a bash study group on Sunday or Saturdays where they go and they work on that stuff all the time. I'm getting pinged from work. What is this? It's like almost 6 at night. That's like that's 9 o'clock for those guys on the East Coast. That's late. But well, the weather service is always running, so we always have people on call. But what is that user? Bin poosh. Yeah. Or PowerShell. You guys can, so here's the thing, right? And by the way, sometimes I'd like to explain this. Does anybody know why I have to do a // to run this script? Or alternatively, I could do this, right? I can run it like that. But why, this is a fun one. Why doesn't that work? Does anybody know why? And for sure, why doesn't it work for me? Why for sure does it not work for the root user? But I'm gonna leave you guys to think about that, right? So let me clear that up. Why does this work, but this does not work? Right? I'm gonna go take a break real quick. Pull up my little hourglass. Quick break. I'll say quick break and think about my question. I'll put this up here so you guys can still chat on there with each other. All right, let me turn off my camera. All right, I'll be back. You guys think about it. That is exactly right, the path. What about the path? Oh, I didn't mean to make that 14 minutes. Jeez, that's a long break. I meant to make that 10 minutes. It's definitely the path. Yep, it's definitely if the path's right. It's definitely it. I'll hop back on here in a couple minutes. I'm just stretching my legs a little bit. I've been sitting all day. Well, I wrestled this morning and I thought I popped my damn Achilles. That was fun. All right, you guys keep working on stuff. I'll be back. I'm just wandering out. That's exactly right, Squawker. That is right. And there's a very specific reason why root never can run things from the local path, the ./. You always have to manually do it. There's a reason you never want to put that in root. There's a very, very specific reason. Because if you ever look for something in the wrong directory and somebody's managed to put malicious code, you may run that instead of the command you intend to. Alright, I'll wander around. I'll be back. Alright, I'm back, guys. Just wandering around a little bit. Yep. Let me turn my camera. Whoops, my camera back on. Back hooked up here. Okay. Yeah, that's exactly why. So, you guys were mentioning it, but it's if we echo our $ path, we don't have dot. Dot is if you do an ls-a, you always see these two directories here, dot and dot dot, and dot is always referencing you. So I can ls-ld on dot, and that's the directory I'm in, and ls-ld dot dot is my parent. That's my parent's directory, right? So that would read as /root because we're in root lab essentials, right? Well, the reason this is important is because you don't want root to just run things. Like if I was just in here and did the ls command and somebody had managed to put some code in here called ls, like this would be this is why you can never exec in temp. /temp is a no exec directory for security reasons, because if somebody did muck around with their permissions and because I could put that in the path, the dot, but if I go to temp and somebody happens to get me to execute some ls code that gives them permissions or compromises the box in some way, I'm executing something different than the ls that I thought I was doing, right? So there's like it's a bad practice. So you don't want root executing out of dot ever. He can root can execute out of things down in root's home directory. So like in this, there's a root local bin, so I can go put things in root local bin if I want, but no other user can write there. So the main thing is you don't want to execute from a world writable directory ever, right? Because somebody could again just drop anything in /temp. It's world writable. You execute in there because you added dot to your directory and you maybe fat fingered ls and did SL instead. Have you guys ever seen that before? I don't think it's on here. You guys ever seen SL? This is SL. You guys know what that is? There's no way out of it either. If you ever SL, some admins like to install this so that if you're ever presenting and you type SL instead of LS, the steam locomotive comes through. Yeah. Yeah, it's like the train of shame, and then you just have to sit there like until that's done. It just slows down the meeting, right? Yeah, because LS would show me this, but SL would do this. So that's been around. Yeah, moo. Yeah. But I would not type moo nearly as much as I'd probably type SL. But it definitely has probably done more over the years to like make engineers think about training and security and stuff than other things. I remember reading a thing one time that said not getting rickrolled. So does everybody here know what a rickroll is? I think you guys probably do. Never gonna give you up, never gonna let you down, right? That guy. That has done more for like cybersecurity than like every other effort that any company's ever put together, because nobody wants to get rickrolled, right? So I always thought that was funny. Was they would always use that. So, all right, more stuff, more operations, just more stuff to work through. This is all extra to the course, but it's more stuff. And then we go into, now we only barely get to Unit 2, right? It will be duck roll. Understanding and configuring SE Linux. So I think we have SE status is disabled on these boxes, but we could turn it back on. I had it on the old Rocky boxes. We should probably turn it back on so you guys can play with it. But you can still use ls-lz, and even in an unlabeled file system, you can still see the contexts if they were labeled and did exist, even if it wasn't getting apt-get moo. So for me, it's DNF what provides. There is no moo apparently. But they must have thought it was too silly on rel to do it. But let me see if I have. Whoops. Do I have? I have the EPEL repos. And oh, but they are not. Oh, they are enabled. Yeah. So we might not have any equivalent of moo. Moose minus the enters. Tiny moo? Is there a moo moo? I don't see anything. It's a Debian. Okay, so it's over on Debian. We can get into a Debian system if we needed to, but yeah. So anyways, the point is, as we go through these, we won't go through all this. I'd probably have to get off of here in a little bit anyways, because I think the wife's going to be heading home soon. These things are all recorded. So if you're going through the course books, which again, all this stuff's free, you can get the access here to, you can watch the videos, right? Here's the YouTube videos on it. Unit 2 recording for when we did it. Utilization, saturation, and errors, how we look at the system, what's going on in there. It's me sitting there talking to you, and then you get down into the labs, right? Then you go do all the lab stuff. Just all the system stuff. This one is just checking out a system, start to finish, what's going on, all that kind of good stuff. All right, Proxmox doing good. File test operations, that was tldp.org. We talked about all that. What else did we have? I think that's probably good. Last thing we got to do, reboot the box. And that'll come up clean. Let's see what these guys are messaging me about. I'm in some thread that people are talking a bunch in right now. Okay. We can go back in there here in a second. Give it about 20 seconds is what it takes in the environment for these boxes to come back up, because they're pulling their image from werewolf. So give it a few more seconds here. Rocky's back up clean. If we go into root, all of our work is gone, right? Because it just blows it away. If you ever need to do anything persistent in the lab environment, all of the persistence of our lab environment is down here in lab work. So if I do mount grep-i for NFS, here's all the NFS mounted locations. So home is mounted read-write, lab work is read-write, and then labs are read-only, and opt is read-only. So yeah, so lab work is read-write. So if you needed to do something, you can go into like lab work, and then I could mkdir Scott examples or something like that, and then in there I would be able to do whatever, and then it would be persistent over reboots. Most things in our environment are not persistent over reboots because they're stateless nodes, right? So that's kind of a thing to think about there. All right, well, what we should do is probably raid out somewhere, see what's going on out there in the world. I think I know where we're going to raid over to, but I appreciate everybody coming by. We will I will be out of the city for the next few days, so I'm not going to be back in town until later on Sunday, so I probably won't have much. I won't do much hanging around on the internet, but yeah, for YouTube, I will see you guys later on in the week.